We live in a world mapped by satellites, photographed from space, and explored down to the smallest streets and mountains. Yet beneath the surface of our own planet lies a realm still largely unknown. While we can see distant galaxies and study planets millions of kilometers away, more than 95% of the ocean remains unexplored, unseen, and unmapped. The ocean becomes truly terrifying as you descend, because, at great depths, reality itself begins to behave differently, and the creatures that survive there reveal how extreme and unforgiving this world really is. Around 200 meters below the surface, sunlight nearly disappears, and by 1,000 meters, the ocean enters permanent night, a zone where over 90% of living organisms produce their own light through bioluminescence. Not for beauty, but for survival, deception, and hunting. The anglerfish uses a glowing lure filled with symbiotic bacteria to attract prey in total darkness, while the dragonfish emits red bioluminescent light that most deep-sea animals cannot see, giving it a private hunting spotlight in a world where red light should not exist at all. At these depths, pressure increases so dramatically that a human body would be crushed instantly. Yet, animals like the barrel fish have transparent skulls filled with fluid, allowing their eyes to rotate upward and forward to track prey silhouettes above them, an adaptation that feels almost science-fictional. Descend further into the abyssal zone, past 4,000 meters, and life becomes even more unsettling. Here, the giant isopod, a distant relative of the pillbug, grows to the size of a house cat, evolving massive armor, like exoskeletons to withstand pressure that would implode steel. Food is so scarce that many creatures, like the gulper eel, have expandable jaws and stomachs capable of swallowing prey larger than themselves, because missing a meal could mean starving for months or even years. Some deep-sea organisms, such as the Greenland shark, grow at an unbelievably slow rate, with radiocarbon dating suggesting lifespans exceeding 250 years, meaning some individuals alive today may have been swimming the oceans before modern civilization existed. Even more disturbing is the fact that decomposition works differently in the deep sea. Cold temperatures and lack of oxygen allow dead bodies, human or animal, to remain preserved far longer, which is why shipwrecks and drowned remains often appear eerily intact, creating underwater graveyards frozen in time. At hydrothermal vents, where temperatures can exceed 400 degrees Celsius, tube worms thrive without mouths or digestive systems, relying entirely on chemosynthetic bacteria inside their bodies to convert toxic hydrogen sulfide into energy, proving that life can exist without sunlight at all. This discovery fundamentally changed science because it suggested that life could exist on other planets or moons with no sun, such as Europa or Enceladus. Some squid species living in the deep have evolved eyes the size of dinner plates, not to see clearly, but simply to detect faint flashes of bioluminescence from predators or mates kilometers away, while others detach glowing body parts to distract attackers, escaping into darkness as the light fades. Sound in the deep ocean is equally unsettling. Low frequency noises can travel thousands of kilometers, and scientists have recorded unexplained sounds like the infamous bloop, louder than any known animal, reminding us that even today, not every sound source has been fully identified. The deep ocean also contains the largest continuous ecosystem on Earth, yet less than 5% of it has been explored, meaning below the familiar depths already described. The deep ocean is shaped by individual species that survive through highly specific, almost extreme behaviors, perfectly tuned to darkness, pressure, and scarcity. The snailfish lives in the deepest trenches on Earth, including depths greater than 8,000 meters, where pressure would crush most known life. Instead of resisting this force, its body is soft, gelatinous, and nearly boneless, allowing pressure to pass through it without damage, while special molecules called piezolites stabilize its proteins so its cells continue functioning. Normally, the vampire squid, despite its name, is neither a true squid nor an active predator. It survives in oxygen minimum zones where almost nothing else can live by drifting slowly, feeding on marine snow. Tiny particles of dead organisms and waste, using long, sticky filaments, conserving energy so efficiently that it rarely needs to flee from predators at all. The frilled shark, often called a living fossil, hunts by suddenly bending its long eel-like body into a tight curve and lunging forward, using rows of needle-shaped teeth to trap prey that has had no evolutionary reason to recognize such an ancient hunting method. The six-gill shark, one of the deepest living sharks, patrols the darkness slowly, relying on smell rather than vision, rising toward the surface only at night to feed, before sinking back into the depths by morning. A daily migration that has gone unnoticed for millions of years. The goblin shark uses electroreceptors in its snout to detect the faint electrical signals of prey hidden in darkness, then launches its jaw forward at extreme speed, extending it outward from its skull, like a projectile to snatch prey before it can react. The tripod fish lives on the seafloor where currents are weak, standing motionless on elongated fin rays that act like stilts, allowing it to hover above the mud while sensing vibrations from passing prey, conserving energy by barely moving for long periods. The cookie-cutter shark survives not by killing large animals, but by taking small circular bites of flesh from whales, dolphins, and large fish, using suction and razor-sharp teeth to remove plug-shaped chunks of meat before disappearing back into darkness. The chimera, also known as a ghost shark, uses sensitive nerve endings on its snout to locate buried prey, crushing hard-shelled animals with specialized grinding teeth, while spending most of its life far beyond the reach of sunlight, ensuring reproduction in a world where encounters are extremely rare. The deep-sea octopus known as granaldune guards her eggs for over 4 years without feeding, slowly deteriorating as she protects them from predators and currents, dying shortly after they hatch, making it one of the longest known brooding periods of any animal. The siphonophore, a colonial organism often mistaken for a single creature, is actually made of thousands of genetically identical individuals working together as one body, coordinating movement, feeding, and reproduction while stretching longer than a blue whale through the darkness. In the deepest zones, the amphipod survives crushing pressure by incorporating aluminum into its exoskeleton, forming a protective gel that shields its tissues. A natural material science solution humans still struggle to replicate. The deep-sea hagfish defends itself by releasing massive amounts of slime when attacked, clogging predators' gills and allowing it to escape, while also feeding by burrowing directly into dead animals and consuming them from the inside out. The giant squid, rarely seen alive, relies on massive eyes to detect faint disturbances in the water, using long feeding tentacles armed with rotating hooks to capture prey in sudden strikes before retreating back into darkness. The barrel jellyfish drifts through the deep ocean like a living trap, providing shelter to small fish inside its bell while feeding on plankton, turning protection and predation into a single survival strategy. The Hadal snailfish lives deeper than almost any vertebrate ever recorded, pressing itself against the seafloor of ocean trenches, where pressure exceeds 1,000 times that at the surface. Instead of bones strong enough to resist this force, its skeleton is barely hardened at all, allowing the pressure to pass through its body harmlessly, while its cells are chemically reinforced so they do not collapse. The vampire squid survives where oxygen levels are so low that most animals would suffocate within minutes. It drifts slowly with almost no movement, feeding on falling debris called marine snow. And when threatened, it does not flee, but turns itself inside out, exposing spiny looking filaments and glowing organs to confuse predators before vanishing back into darkness. The frilled shark, unchanged for tens of millions of years, hunts by coiling its eel-like body and lunging forward in a sudden strike, using rows of backward-facing teeth that prevent prey from escaping once bitten, a method so ancient that modern animals have no instinctive defense against it. The six-gill shark, which patrols depths rarely reached by light, rises silently toward the surface, only at night, feeding under cover of darkness before sinking back down by morning. Repeating this vertical migration every day for decades without ever being seen. The goblin shark detects prey using electroreceptors in its elongated snout, sensing the faint electrical impulses produced by muscle movement, then fires its jaw forward like a spring-loaded trap, extending it far beyond its skull in a fraction of a second before retracting it with its prey already captured. The tripod fish stands motionless on the seafloor on long, rigid fin rays, balancing above the mud for hours or days at a time. The cookie-cutter shark survives by taking precise circular bites out of animals many times its size, using suction and razor-sharp teeth. Together, these species reveal that the deep ocean is not a place of random survival, but a finely tuned system where every movement, every adaptation, and every behavior is shaped by darkness, pressure, and time. Nothing here is wasted. Energy, light, reproduction, and motion are all used with ruthless efficiency. These creatures do not fight the deep ocean. They cooperate with it, becoming extensions of its rules rather than challengers of them, proving that life beneath the surface survives, not through strength or intelligence, but through precise adaptation to an environment that has never needed humans.